Hi everyone. So today's topic of discussion is polymorphism. Polymorphism is derived from two Greek words, that is poly and morph. Poly means many and morph means forms. For anybody to be present in more than one forms is called polymorphism. It can be in your real life or in your programming language. When it comes to programming language, for an object to take many forms is what we call polymorphism. So this is one of the core concept of object-oriented programming that allows methods to be present in more than one form. Like you can have method overloading or method overriding. So these concepts comes under polymorphism. So this becomes very important in object-oriented programming. When we talk about object-oriented programming, there are three main concepts. One is inheritance, the other one is encapsulation, and third one is polymorphism. Inheritance and encapsulation are themselves very huge topic. We can discuss it over some other video. Here we are going to discuss about polymorphism. Let's talk about some real world example. Let's say we have a man. He can be a father, he can be a husband, an employee, or a brother. A man can perform different tasks. He is also an example of polymorphism. Then comes your shapes. So you can have circle, you can have square, you can have rectangle, octagon, and multiple shapes. These becomes examples of your polymorphism. We have discussed about polymorphism, but why do we need polymorphism? What are the advantages of polymorphism? One is you have same method for different types. Since you have same name for different data types, you can reuse the method calls and you can reuse your code. Second is it is flexible and maintainable. It's easy to add new functionality. Let's say you had a sum function for 2 variable and 3 variable. Now you want to add a function for 5 variable. You can easily add that. So it's very flexible and maintainable. Also, it improves readability because you have fewer method names. Let's say you have 5 overloaded function, but all 5 would be having the same name. So your code becomes simplified. When it comes to types of polymorphism, we basically have two types of polymorphism. That is compile time, or we can call it static polymorphism, and the other one is runtime or dynamic polymorphism. Compile time polymorphism is resolved at your compilation time. Means if you have overloaded your function or operator, so what has to be done at that situation, that compiler decides when you're compiling the program. For method overriding or virtual function, the compiler decides what has to be done only at the runtime. That is why it is also called dynamic polymorphism. For one function call, you might be calling either the base class function or the derived class function. So your definition can change according to the need. Starting with compile time polymorphism, we achieve compile time polymorphism through two ways. One is method overloading and the other one is operator overloading. Method overloading, we can also say function overloading. Starting with function overloading, when we can have more than one function with the same name in our program in the same scope, that is called function overloading. Main thing is they have the same name and the scope is also the same. If you define more than one function with same name, that can give you compile time error. So what is the thing through which we can achieve this is either they will have different parameters or they will have different number of parameters or they will have different order of parameters. Out of these three conditions, what one should be met, otherwise it will give you an error. If you say that, okay, I have exactly the same function, but my return type is different, then it is not an overloaded function. It will also give you an error. For overloading function, return time doesn't matter. The second thing would be, why do we need function overloading? The basic answer is it increases the readability of your program. When we talk about best practices of any programming language, one is your function name should define what your function is going to do. Let's say I have three functions. All three are adding something. They are giving the sum of something. One is taking some integers, the other one is taking double, and the other one is taking float variables. If you don't have overloaded function, you will either have to define them as sum1, sum2, sum3, but that won't be very readable. So you will try to give some other name, but actually all of them are adding something. So you need to give similar name to them. In that case, you can give all of them same name. Even while using, it becomes very easy to use. You don't have to worry, okay, if I had integers, I had to use sum1. If I had double, I had to use sum2. If I had float, I have to use sum3. It's also very readable. Your function name do define what you're doing inside the function, and also it's very maintainable. You can easily add on or decrease whatever you want to do. One thing to remember over here is when you are overloading any function and while compiling, your compiler is not able to decide which function is to be invoked. Let's say you had integer, double, and float, and for some reason your float got casted to integer. Now the compiler is not able to decide whether to call your float function or your integer function. In these situations, the compiler gives you an error, and that is ambiguity error, because these are ambiguous. Compiler is not able to decide which function to call, and hence it will not run the program. It will give you an error. This is an example of your function overloading. Here, if you see, I have used the same function name for 3 times. What change I have made is, in one function I am having an integer parameter, in the other function I am having a double parameter, and the third one I am having two parameters. So this way I can overload my function. When I call this function, let's say I called this function func and I provided one integer. At that time, your compiler will know, okay, this function has to be called. But if I provided a double, the compiler will know that this function has to be called. And if I provide two integers, the compiler will know I have to call this function. In that way, compiler decides which function has to be called. The other type of compile time polymorphism is your operator overloading. Now, what is operator overloading? Let's say you have a class, you have some objects of that class. Now, let's say you want to use some operators on those objects. By default, you cannot do this. Why? Because your compiler doesn't know what functionality has to be performed in such cases wherein you have used your increment operator or any other operator in your user defined data types. So how can we do this? We can achieve this by using operator overloading. Now what we can do is we can define what the operator has to perform when it is used with an object in a class. Let's say you have some class and you want to use increment operator. So you will define what you have to do when this operator is used with the object of this class in your class itself. That is how you can overload the functionality. One more thing to remember over here is there are certain operators that you cannot overload. That means there are some functionality that are by default used and you cannot overload that functionality in your program. So what are these? First is your scope operator. When you're using the scope operator, use it with your class name and you want to refer to some member of the class. At that time you use your scope operator, so you cannot override the functionality of this one. Then your size of operator, because size of operator is also used by your class, so you cannot use the size of operator. Then your member selector. With object name you select some members of your class. So this again is used inside your class. So its functionality also cannot be overloaded. Then comes your member pointer selector. This is used to select some members. So again, this has some functionality in your class, so you cannot overload this one also. Then comes your ternary operator. Ternary operators are themselves very difficult to understand. So ternary operators are also the ones that you cannot overload in your class. This is an example of your operator overloading. Here you can see how we can use operator overloading in our program. First thing is your return type. When you are using that operator, what would be the return type of that operator? Then you use the keyword operator. Only when you use this keyword operator, the compiler knows, okay, you are overloading some operator. So this functionality has to be overloaded. And this functionality is to be used when you use this operator with the object of this class. Then you can have parameters, and then you have the body of your operator overloaded. Let's say in this example, I have a variable num. When I create an object of this class, it assigns num with 8 value. Now, let's say I created an object A and then I use this increment operator. In that case, what the compiler will do is it will go to the object of that class, then it sees, okay, I have to perform this. So it will do num equals to num plus 2. So it will change the value of num to 10. That way we can use operator overloading. After compile time polymorphism, we come to runtime polymorphism. Now, what is runtime polymorphism? Let's say you override some method. Then what has to be done in such situation? The compiler will decide at the runtime. That is why it is also called dynamic binding or late binding, because the body of your function call will be replaced only at the runtime, not at the compile time. So at compile time, your compiler doesn't know which functionality has to be called. That will be decided at the runtime, and that is why it is also called dynamic binding, because it is done dynamically. In runtime polymorphism, first thing that we need to understand is method overriding. Method overriding is the way through which we achieve runtime polymorphism. Now, what is method overriding? Method overriding or function overriding is one and the same thing. In this, let's say you have a class shape and your class shape has a function display. Now, for your subclasses, you redefine this function. Let's say first one was your shape class, and then you derive two classes from it. These are circle and square. Now you have your display function. So circle will have a different definition of display function, and your square will have a different definition of your display function. In that way, your base class display function is overridden with the display function of either your circle class or your square class on the basis of what object you are using. In that way, you can override the functionality of your base class. If you don't override the functionality, your subclass will use the functionality of your base class. But you can redefine the functionality. That is why it is called overriding. Now, one thing to remember over here is when we were using method overloading, our functions name were same, but we were changing the parameters. But here when we are using runtime polymorphism, our function name as well as function parameters has to be exactly same with the base class. If we don't do that, then your function will be considered as a new function, not the overridden function. This is an example of your method overriding. Here you can see I have a class animal which has a function eat, and what this function does is it displays eating. Now I have another class that is inheriting class animal, but it has redefined the function eat and it says eating bread. Now you can notice our eat function are exactly the same. If you have this dog class, you'll have its member function as this eat, not this one. In your main, you create an object of this class and you call this function. So you'll see that this call will be this eating bread call, not the animal one. You can also see the output is eating bread because the derived class function is called, not the base class function. One more very important functionality that comes under runtime polymorphism is your virtual functions, also called as virtual methods. These are the member functions that were declared in your base class and are redefined in your derived class, exactly like your function overriding. But here is a catch. When you refer to a derived class object using a pointer or a reference to the base class, you can call a virtual function for that object and execute derived class version of it. This virtual function comes into use only when you are using pointers in C++. When you are using pointers in C++, you can use your base class pointer to point to your derived class. This becomes very useful because you only create a pointer of your base class, and if you have multiple derived class, you can use the same pointer. In that way, your code becomes very readable. At the runtime, your compiler will decide, okay, the base class function has to be called or the derived class version has to be called. This is what we call virtual function. So this is the same thing, that which function has to be called, it is decided at runtime regardless of whether you are using your base class pointer or the derived class pointer. Basically, it is used for function call. One more thing to remember over here is when you are defining any function as virtual function. So let's say there is a functionality which you want to use for multiple classes, but you want your code to be simple and you want to use single pointer to point to multiple derived class. Now, for you to use this functionality, let's say you have a display function in your shape class. You want to use your shape class pointer to either point to your circle class display function, your square class display function, or your rectangle class display function. One thing to remember over here is you have to use this word virtual in your base class. If you don't do that, then you cannot use it. If you try to use that, your base class function would be called if you are using pointer. So you have to be very careful and you have to use your virtual keyword. Now we have an example of your virtual function. We can define your virtual function using the keyword virtual. Here we have two functions in our base class and both are redefined in your derived class. You have your virtual function print and other function show in your base class, and in your derived class you again have your print function and you have your show function. Now you see you have created a pointer of base class and you are assigning the memory address of your derived class to this base pointer. Now the base class doesn't know anything about show. It is overriding in your derived class. Base class doesn't know anything about your derived class. So when you call base class pointer show, it will actually call this show function. But when you say that you are calling a virtual function, your compiler will see, okay, your derived class has any print function or not, and it will call this print function. So the output should be print derived class and then show base class, because show function is not a virtual function, so your compiler will not look for any other show function in your derived classes and it will simply show your base class. Now let's see the output. We have actually called print of the derived class and show of the base class. So that is how your virtual functions work. Now we have seen about method overloading and method overriding. Let's see what are the difference in method overloading and method overriding. First comes your definition. When you're defining your method overloading, your method name has to be same, your function name has to be same, but you have to use different parameters. But when you are using method overriding, you have to use the same name and same parameters. So you actually redefine inherited method. At what time they are performed? Your method overloading is performed at compile time. Your method overriding is performed at runtime. When it comes to usage, when you're overloading methods, it is done in the same class. When it comes to C++, you can also overload methods outside the class. but it has to be in the same scope. When you're talking about method overriding or function overriding, these are done using inheritance. You have your method in your base class and you redefine that method in your child class. That is called method overriding. So it is performed across classes, but method overloading is only performed at the same scope. One more difference which we can say over here is in C++, your method overloading can be present outside class, but your method overriding cannot be performed outside classes. If you have anything, you can share me. Thank you.